few milliseconds. Such mysterious flashes are called fast radio bursts. They seem to be coming from billions of light years away. Not so long ago, researchers were lucky enough to capture a repeating radio burst that flashed 6 times in a row. Who knows, it might help us crack the puzzle of these signals. But hold on, it's just the first mystery on our list. If nuclear pasta does exist, it's the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance is squeezed into spaghetti-like tangles of material. It can break, but only after you apply 10 billion times the pressure needed to shatter steel. That single, high-energy neutrino that hit Earth in 2017 wasn't extraordinary on its own. Scientists observe such neutrinos at least once a month. But it was the first one to arrive, carrying so much information about its origin that astronomers could actually point their telescopes in the direction it had come from. They found out that the neutrino had been flung at our planet around 4 billion years ago by a flaring blazar, a supermassive black hole at the center of a galaxy. Saturn's moon Hyperion is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity which is flowing out into space. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras illuminating the planet's atmosphere. When a team of astronomers at Louisiana State University first spotted this star, they were totally baffled. The object, nicknamed Tabby's star, dipped in brightness at irregular intervals and for odd periods of time. Sometimes the difference in brightness reached 22%. Could it be due to the activity of some alien megastructure? Unlikely. The main theory claims that the star is surrounded by an abnormal ring of dust, which causes the darkening. DJI-SAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters. It can mean that DJI-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Massive objects curve light so much that it can distort the images of objects behind them. When astronomers used the Hubble Space Telescope to detect a quasar from the early universe, they used their discovery to calculate the expansion rate of the universe. Strangely, they discovered that, currently, it was much faster than it used to be. That finding contradicted other measurements. We still don't know if our theories are wrong or if something bizarre is going on in our universe. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star. But this theory hasn't been proven yet. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most enigmatic thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Dark matter is believed to make up 85% of the universe, and researchers used to be sure it was everywhere. But in March 2018, a team of scientists discovered a peculiar galaxy that seemed to contain little to no dark matter. Later, though, it was proven that this space oddity did, in fact, contain dark matter. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this yet. Planets orbit stars, moons orbit planets, then why can't there be moons, also known as submoons, moonets, and muons? Researchers claim that moons could exist. But the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Count how many times the word moon is said in this video. Enjoy! There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't sub-moons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile-wide submoon could only survive moving around a 600-mile-wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core, but the inner core was hard to study. so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the sun and from space. But even though Saturn is protected by its magnetosphere, the sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese Lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the moon. The Earth has numerous satellites circling around it, but the moon is the only natural one. Our moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the moon, leaving craters as a reminder of this collision. If you're standing on the surface of the moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile-wide asteroid and its 1-mile-wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands, or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. Sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington Event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus the strongest ones, X-class flares, have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then. From thousands of dollars worth of treasure to brand new phones and ancient cities, let's dive into the water and see what we can find. Imagine going to the river to enjoy a boat ride. Who wouldn't want to take a couple of pics to make the memories of this trip last forever? Oops, the water split. Luckily, you've taken precautions and put your gadget in a waterproof bag. But what if you drop your phone to the bottom of the lake along with this case? This is what happened to some people. A scuba diver and a YouTuber dived into a river popular with tourists and lost some of their gear worth $20,000. Including new iPhones and some jewelry. Oops. You might be familiar with the image of a car getting pulled out of the water, either from the movies or TV news. Large cargo vessels sometimes sink, and trucks inside them go along. That's what happened with the Thistlegorm wreck. It sunk in 1941 in the Red Sea, and these Bedford trucks were inside. Want to see something more valuable, like treasure? A British cargo ship was carrying a heavy load of silver ingots, but the vessel sank. Treasure seekers knew there was silver on the ship. Since the 1940s, they've been looking for it. The Odyssey Marine team got lucky. They made the discovery in 2011. The treasure was more than 14,000 feet below the surface. The ship had carried more than 110 tons of silver ingots. Finders keepers! The Odyssey team kept 80% of the treasure and gave 20% to Her Majesty's Treasury. Of course, there were more items on the ship, like letters, teapots, and silk sheets. You can see them in the exhibition called Voices from the Deep at London's Postal Museum. Now how about some underwater art? Sure, here you go, Polynesian moai statues. These statues have been discovered in several areas across the world. For instance, Easter Island is full of different size statues, but many of them can also be found in Cancun, Isla Mujeres, and Punta Nizu, Mexico. Seeing full-body statues from thousands of years ago under the water would probably be a lifetime experience. Gold coins are also popular items found in shipwrecks. Many divers come across coins worth a lot of money. But there's one diver in Florida who truly hit the jackpot. In 2015, they stumbled upon nearly $1 million worth of treasure. The discovery was 51 gold coins, 40 feet of ornate gold chains, and a rare coin that was made for Philip V, the King of Spain. They were once frightening and dangerous, and they still look spooky. Yo-ho! I'm talking about pirate ships. One pirate shipwreck from the 18th century was excavated off the coast of Colombia in 2015. The treasure found there was worth between $4 and $17 billion. It contained precious stones, gold, and many other items. The next one is an underwater city. Neapolis is a city washed away by a tsunami. It was built on the coast of North Africa nearly 1,700 years ago. Divers uncovered the city's remains in 2017. Researchers have also discovered Roman columns, as well as household goods and tools. Now, let's go all the way back to 1503. Portuguese explorer Vasco da Gama was fighting a storm when he lost his ship Esmeralda. The ship was discovered in 1998, but it had to wait for more than a decade to be excavated. Researchers found navigational tools there. They didn't have as much value as Spanish gold, but they were historical treasures. Now, in Amsterdam, they fish for bikes in canals. 1/3 of working Amsterdammers cycle to work. Others use their bikes for different purposes, like exercising, going shopping, and so on. There are more bikes in Amsterdam than permanent residents. Unfortunately, many bicycles and even some cars end up in Amsterdam's canals. The fact that Amsterdam has 165 canals with a combined length of 60 miles doesn't make the authorities' job easier. Obviously, the owners don't throw their bikes into the water. Bikes can end up in the canals because of strong winds, vandalism, theft, or by accident. Every year, authorities fish up between 12,000 and 15,000 bikes. Our next one is a lost city. Heraklion was ancient Egypt's gateway to the Mediterranean. It became submerged and hidden under the sand. This city was famous. Maybe you've even heard about it. It was mentioned in the legend about Helen from Sparta and Paris from Troy. So, how was this ancient city discovered? In the early 2000s, a team of divers found a huge fragment of rock on the seabed and took it up to dry land. It turned out that it was a piece of the statue of Hapi, who was the lord of the river of ancient Egyptians. The team continued searching and found 6 other pieces. Around them, they saw temple ruins, pieces of pottery, jewelry, coins, oil lamps, and so on. Even an old copy of the New York Times. Nah, not really. Granada Underwater Sculpture Park is the world's first, what else, underwater sculpture park. Why is this park so special, besides being located in the beautiful waters of the Caribbean? You can see the park on a snorkeling or scuba diving trip. The sculptures are about 9 to 16 feet underwater. The atmosphere and the experience itself make it special. The sculptures are made from concrete and steel. Some of them weigh as much as 15 tons. They're covered with underwater creatures. The statues were put there to help protect reefs, maintain the health of the ecosystem, and restore underwater life in that area. Now, submarines are designed to go underwater, so maybe you wouldn't expect to see them on this list. But submarines do, in fact, sink. Divers have discovered many submarines. For instance, an Australian submarine was found off the coast of Papua New Guinea more than a century after it had sunk. Now here's another submerged city, but this one was left underwater on purpose. You can see the ancient ruins of Lion City in a lake in China. This lake was created in 1959 when the valley, at the base of Five Lions Mountain, was flooded to create a hydroelectric power station. The 1,400-year-old city, now ruins, got submerged by this flow and stayed this way for over 50 years. It lay untouched at the bottom of the lake until its exploration started in 2001. Divers found out that many structures, carvings, guardian lions, and arches were still preserved. Researchers mapped and documented Lion City. They also looked for a way to protect these structures from further damage. In 2011, the city was announced to be an historic relic under protection. When you see the ruins of Lion City for the first time, the view will take your breath away. So don't forget to hold your breath. Imagine swimming in the dark waters. As you're approaching the city, you see its huge walls and extensive carvings. Marvelous, isn't it? The Cancun Underwater Museum is probably the largest museum of its kind in the whole world. It wasn't lost, per se, but now it's home to an aquatic ecosystem. Who wouldn't want to combine scuba diving and snorkeling with a visit to a world-class garden with 500 sculptures? Placed 30 feet under the surface, these sculptures are made from pH-neutral marine concrete so that they can stay on the ocean floor. Plus, here, the sculptures change over time, unlike in a traditional museum. That's because they become part of the underwater environment and a home to various plant and animal species. In one installation, nearly 450 life-size figurines are grouped together to hint at the harmonious coexistence of humanity. There is also the Anthropocene, which is an actual submerged Volkswagen Beetle placed by the Manchonis Reef. Okay, this is not a lost and found item, but this is just, hey, it's a giant jellyfish and I wanted you to see it. This creature is known as the lion's mane jellyfish, and is the largest known species of jellyfish. So, I'm happy now. And have you ever discovered anything underwater?
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blow-torched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.
The moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020's CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface, discovered by NASA, might be the openings to lava tubes. The moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the moon. Yet, many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them.
Consider now
Enceladus,
Saturn's icy moon. one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because Enceladus's ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's Cosmic Dust Analyzer, researchers have detected phosphorus. Enceladus is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of Enceladus and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On Enceladus, there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But Enceladus and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, The biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the Earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Now, what would Earth look like if it was the only planet in the solar system? Or, what would happen to our planet if the moon went missing? Or, what if dinosaurs had never gone extinct? We've all heard the story. Over 66 million years ago, a big asteroid hit Earth. Almost 75% of creatures that roamed the planet at the time were wiped out in mass extinction. Among them, dinosaurs. Tyrannosaurus, Triceratops, Velociraptor, all gone. But because of that, we're all alive. According to science, the human race was developing more safely without these gigantic creatures hunting us. But what if that asteroid had crashed to the ground a few miles away from the place where it fell? What would the world be like today? Imagine walking down the street to your local supermarket and coming across a truck-sized T-Rex. Could that ever happen in this alternate universe we're talking about? Well, dinosaurs would have had to survive a lot more than an asteroid to be living nowadays. About 55 million years ago, the temperatures on the planet rose. The climate became 14 degrees Fahrenheit hotter than it is today. Rainforests flourished, and vegetation was abundant. In this scenario, herbivore dinosaurs would have likely thrived. But they would have started to look a bit different. Plants started growing during that time period were not very rich in nutrients. This means that dinosaurs would have probably shrunk in size, not having the necessary energy to grow all the way to their full size. Then, about 34 million years ago, South America and Antarctica split, which resulted in a cooler and drier climate. During this period, long-legged dinosaurs would have been the ones to survive. At that time, animals had to travel long distances to hunt, since seasons started to affect the availability of food and water. Compared to the mammals of that period, dinosaurs would have had significant advantages, like having more teeth or better eyesight. And speaking of mammals, some of them probably would have never evolved. That would have become dinosaurs' breakfast first. By the way, did you know that some dinosaurs live among us today? Think pigeons, or birds in general. They've all evolved from dinosaurs. Now, I bet you've heard once or twice that we use 10% of our brains. If this was true, what would happen if you used 100% of our brain? Would you be able to compose a symphony? Would you become a tech genius and create a multi-million-dollar company overnight? Let's start with the facts. We don't only use 10% of our brain. This notion became highly popularized by movies, but it's not very accurate. The truth is, the largest portion of your brain is active at all times. But not all parts are working simultaneously. The exact percentage varies from person to person. Now, neurologists say you wouldn't be using 100% of your brain's capacity at once. Your body simply wouldn't have enough energy for that, which means you'd be hungry all the time. Imagine the number of calories you'd need to consume for that to work. You would also be limited by your body's basic needs: breathing, digesting food, and circulating blood. So if you did use all of the capacity of your brain, you'd be tired all the time. It'd be worse than running a marathon without any preparation. The brain would need all the blood you'd have, which would mean less oxygen for your lungs. Different organs would begin to shut down one by one. In a nutshell, it'd be terrible for your health. By the way, some researchers have estimated that more than 60% of the brain is composed of something that is called neural dark matter. In other words, this dark matter consists of neurons that have no apparent purpose or simply don't respond to common stimuli. Marathons are some of the greatest feats of strength and endurance in the world. But what would happen to your body if you decided to run a marathon without any training? The statistics are overwhelming. Nearly 50% of participants drop out of the race before crossing the finish line. A regular marathon is 26 miles long, and if you're not used to physical activity, it's a great challenge. You'd probably be able to run the first mile without any serious problems, but breathing loudly and heavily through your mouth. By the third mile, your body temperature would skyrocket, and you'd feel as if you have a mild fever. You'd most likely give up here, but if you decided to keep going, you'd have to trick your mind and body into running another 23 miles. By the 20th mile, you'd hit what is known as the wall. Your body would have burned all your reserves of glucose, and you'd get extremely tired. Even experienced runners often go through this stage. By the end of the marathon, you'd be promising yourself to never do this again. You'd leave the race with at least a few cramps and many food cravings. Now picture this. It's a clear, beautiful night. There are no clouds, and you can see two of the brightest planets in Earth's sky blinking up there. Those are Mars and Venus. Now, have you ever imagined what would happen if Earth was the only planet in the solar system? If the other planets never existed, things would be really different for our Earth. The planets in the solar system work together, keeping one another in certain place with their gravitational pull. Now, if Mercury or Venus ceased to exist, Earth would drift closer to the Sun. Our atmospheric temperature would become similar to that on the surface of Mercury, 800 degrees Fahrenheit. This would make life on Earth impossible. But if Jupiter or Saturn disappeared, Earth would most likely drift further away from the Sun, and its temperature would drop to below -200 degrees Fahrenheit. If life managed to survive in such circumstances, it would probably be aquatic. The position of Earth in the solar system not only affects all kinds of life forms, but it also dictates seasons, the length of days, and how long one year lasts. Now, when we say no other planets, we mean no moons either. So, what would happen if one fine day the moon just disappeared? That would have catastrophic consequences. The moon has the largest influence on Earth's tides. In a moonless universe, tides would shrink by about 75%. This would greatly affect crabs, mussels, and sea snails that live in tidal zones. This would consequently disrupt the diet of larger animals. Eventually, it would affect entire coastal ecosystems. Earth's weather would change. Tides and tidal currents help mix cold Arctic water with warmer water from the tropics, stabilizing the climate worldwide. Weather forecasting would become almost impossible, and the average difference between the hottest and coldest places on Earth would become extreme. The absence of the moon would also influence Earth's tilt. Right now, Earth tilts on its axis at 23.5 degrees, mostly due to the moon's gravity. With no moon around, Earth's axis would wobble between 10 to 45 degrees. Scientists believe that even a slight difference in Earth's tilt can cause huge changes, such as an ice age. Other than this, a moonless sky would upend the lives of many nocturnal animals. Moths have evolved to navigate using the light of the moon and stars. Newborn baby turtles use the moon's light to find their way to the ocean. different animals rely on both darkness and a small amount of moonlight to hunt effectively. Now how about we travel far back in time and imagine what would happen if you lived in ancient Egypt. This civilization lasted for over 3,000 years. Ancient Egyptians were responsible for building some of the world's most recognizable symbols, the Great Pyramids at Giza. If you'd lived in ancient Egypt, you'd have witnessed a time of enormous scientific and mathematical breakthroughs. Ancient Egyptians organized themselves in strict social structures, so you'd probably have to fit into one of them. You'd have either been born a laborer, a farmer, or a specialist, which was either a soldier, a sailor, or a teacher, or you'd have been part of the Egyptian elite. If you had been a farmer, you'd probably live in a house made of mud bricks. You'd have had a stone oven and kept your food stored in a pit in the ground. You'd have spent your days tending to crop fields by the Nile River, or taking care of cattle and ducks. On tax days, you'd have packed up some of your harvest and brought it to the temple as payment for the usage of land. If you'd been a member of the elite, you'd have spent most of your days in banquets. You would have adorned yourself in gold and semi-precious stones, displaying all your wealth. If you had lived in ancient Egypt, maybe you would have been one of those who invented tables. Yep, before the Egyptians, there was no such thing as a table. This invention appeared as a way to keep food off the ground.
Whoa, the light from outside your window just got brighter. It's 9:30 in the evening, and you have a huge exam coming up tomorrow. You peek outside to see if your neighbors use their floodlights again, but they're outside looking up in the sky. You stick your head out and notice that the moon got a lot bigger, double in size. You run outside and ask people what's going on, but they don't have a clue either. You take a picture of it and post it on social media. You view your feed and see that everyone is talking about it. The dark sky is brighter because the moon has more real estate to reflect light from the sun, making the light more intense. You can feel a slight imbalance while walking. Every time you take a step, it feels like you're walking lighter than usual. Because the moon became so large, its gravitational pull became stronger, so gravity became weaker. Suddenly, you look below you and feel your socks are wet. You run and hop on the top of a car and see that there's water flooding your neighborhood. Everyone tries to find higher ground or run back to their houses. This isn't a fire hydrant that busted and is spewing out water. This is ocean water seeping in. You're confused and lose your balance. You slip and fall in the water as it rises. Some people are in their cars, but they can't drive anywhere because of the water. You live near the ocean, but there has never been a tsunami or any flood reports in your whole life. There are no reported earthquakes around the area, so something strange is happening. You run back to your house, trying to see if you can get out your old inflatable raft to help you with the flood. The only problem is that you need to inflate it but don't have your pump. You inflate it with your mouth at first, but it'll take forever to pump it up. You search around your house for an alternative and find your hairdryer. You plug it in and inflate the raft as much as you can until you use your mouth to do the rest. The water level rises by every second and has now entered your house. You pack up a bag with a good flashlight, some food, and thermal blankets. You go downstairs and see that the water is now at your knees. You keep walking until you reach the door. When you step outside, the water pushes you left and right since the waves are very harsh. Since gravity has changed, it's not easy to swim around. You get your raft ready and use it to float yourself down the current in your street. It doesn't help that the water is freezing, and you're in the middle of February. After a while, you reach the highway where water is coming directly from the beach. You manage to get on a high surface and take out your phone. You kept it in a protective compartment in your bag for safety. You only have 15% battery left, but you brought your power bank. You call your family to see what's going on, but they too have no idea. You venture into the forest and try to spot an old cabin you used to visit as a child to see if you left your old bicycle there. After a few minutes, you find it and bike across the mountain to escape the flood. You can't seem to balance yourself since the gravity is affecting you. Some scientists sit around with laptops and spreadsheets, attempting to understand what's happening. Everyone is shouting and throwing out random solutions, but nothing seems to make sense. After a while, the head of NASA decides to launch an unmanned rocket to the moon. The rocket is ready in a few hours, and everyone is awaiting orders. 3, 2, 1, blast off. The rocket soars in the air and approaches the moon. It exits the Earth's atmosphere and travels at full speed in that direction. After a day or two, everyone gets live footage of the giant moon. According to the studies, the rocket can't be too close to the moon since it may have a stronger gravitational pull. However, the footage shows that tiny particles are floating around it, similar to Saturn's rings. These rings look like a giant disk surrounding the large planet, but up close, they're just particles that are the size of rice grains to the extent of a large bus. They're orbiting Saturn because of the gravitational pull. The images show that these particles are big and small, which doesn't make it safe for the rocket to get any closer. So it suspends itself nearby to orbit the moon and unleashes a mini rocket that looks like a drone to get closer. The particles are many miles thick, making it difficult for the mini rocket to maneuver. It flies closer and the particles start crashing on it. It's a good thing that the mini rocket is durable for this. The rocket finally gets past the particles and lands on the moon. Gravity has gotten stronger since it inflated in size, which almost broke the rocket. As soon as it lands, another robot pulls out and starts driving around the surface, trying to get some clues. As of now, nothing is happening. But they're noticing some quivers coming from deep inside the moon. The moon's core is reacting abnormally. It looks like it's getting bigger and bigger. Scientists don't know if it will stop growing at a certain point, so the only way to find out is to drill a hole deep inside to uncover the reason. You're pedaling away and reach the other side of the mountain. The ground is shaking, and your balance is getting worse. You look across the mountain and see that the whole other side of town is flooded. You get your raft and supplies and make it there. You find a rowboat and paddle as fast as you can until you reach the lighthouse. From there, you can try to find the NASA station. Suddenly, you see a large rocket erupt from the ground and into the sky. You know for a fact that your brother is there working, but cellular networks are down. You paddle your way there for safety. The little rocket that landed unleashes a small drill strong enough to go miles to the center. It'll take days for it to reach down. So NASA is already launching another rocket to fly off and bring a bigger drill. The only problem is that the moon is getting bigger, so the particles around the moon also gather a lot more. The moon is reaching the Earth's size, getting bigger by the minute. The flood could reach several coastal states, and many micro-islands could be submerged, so it needs to be prevented. Gravity could affect the structure of most of the buildings, causing them to collapse one by one. But the little robot will not let that happen, so he's drilling to figure out what's going on with the moon. Some of the rocks appear to be getting hotter as it digs. This could be a sign of the moon expanding, which might ultimately explode. The scientists in the room are baffled and don't know what to do. The lead scientist, who is your brother, calls you, but he can't reach you. Meanwhile, you're still paddling around, trying to get to NASA. On your way, you head back to the mountains to stay on dry land. When you arrive back at the old cabin, you see some strange men wearing trench coats looking for you. There's a stare-off until they chase you. They seem odd, like they're not from Earth. The drill has reached its maximum depth and can't go down any longer. Also, the control transmission is getting weaker. Suddenly, a figure pops out of nowhere and flashes its lights on the robot. The transmission chops and only show little snippets of the giant figure eyeing the robot. A little creature descends from the figure and walks toward the robot. Everyone at NASA is freaking out and recording every single frame. No one can believe what's going on. After a while, the creature transmits a signal that NASA can't decipher. But the creature seems friendly. The creature gets back into its ship and in an instant disappears into thin air as it teleports away. The moon starts shrinking. It's getting back to its normal size. Everyone celebrates in NASA and around the world. The currents become calmer and retreat to the coast. It's a good thing everyone reached the higher hills before. The moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color. Very beautiful bluish-green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too. You're strapped in your seat in the vast open space with Earth behind you getting smaller and smaller. All around you are toggles and controls to keep the spacecraft intact. You and 2 other crew members are working hard at those controls. Out the window, you see some meteorites flying by and stars and planets out in the distance. You're about to be one of the first people to land on the Moon after years of research and testing. You have to consider all the steps perfectly. Otherwise, you could face many complications, like crashing into a flying asteroid, or even being left in the vacuum of space without any way of getting on track. Research shows that around 1/3 of all moon landings faced many problems. Launching towards the Moon requires a special rocket traveling at more than 25,000 miles per hour. And once in lunar orbit, the spacecraft can detach itself from the rocket and navigate its way to the surface of the Moon and land. Sounds simple, right? Well, figuring out the math to land was the reason landing a human on the Moon used to seem like a ridiculous idea. But scientists were able to pull it off by studying and observing the flight of helicopters. Unlike an airplane that needs velocity to take off, the large propellers on a helicopter give it a good push to fly around. It basically has to twirl with enough force to lift its own weight from the ground. With that in mind, we need to consider the gravitational force pulling everything down. On Earth, the force of gravity is 32 feet per second squared. On the Moon, it's only 5 feet per second squared. So we got landing on Earth figured out for the most part, but what about landing on a surface that barely assists you in that? There had to be 3 steps, doing all the research and math needed for calculating the proper conditions, using a test vehicle to practice in, and using a flight simulator to imitate the conditions of the moon's atmosphere. Choppers weren't really good references for landing, since gravity is doing most of the work, and the spacecraft looks nothing like a helicopter. They needed to simulate a spaceship of only 5/6 the weight of it. Since the gravitational pull on the moon is weaker than on Earth, navigating it under these conditions is vital for when the real thing comes. The scientists of NASA decided to get a crane hanger to lift the spacecraft with cables while simulating the flight and landing. Kind of like stunt actors in a movie with cables attached to them for action fight scenes. But it still wasn't enough to determine if you could actually land properly on the moon without the safety cables to help you. They needed proper freedom. So it was back to the drawing board. They were about to throw in the towel until they came up with a brilliant idea to simulate the landing conditions on the moon by installing a sort of detachable jet fan into the bottom of the spacecraft to keep consistent thrust upwards. By doing this, they were able to create a scenario where the craft would be 5/6 of its weight on Earth and without the safety cables to hold it. But after many trials and errors, the only way to see if landing on the moon was possible was by actually doing it. So, being so far away from Earth, you and your team see the moon out your window. It's a lot bigger than it looks from Earth. Its surface fills up the entire window. But landing won't be a piece of cake. The spaceship has to orbit around the moon to determine the best time to land. And don't worry, that's why you have a team for that. It can take more than 24 hours to know when and where the perfect place to land is after performing various tests and measurements. And once you get the best calculations, the actual spaceship detaches from the orbiting one and makes its way downwards. This is where the helicopter physics come into play. A helicopter needs to tilt at least 5 degrees to move forward after ascending from the ground. Same for going backwards. But that's because we have gravity to assist it. Up above the moon, soaring through the vacuum of space, the ship would need to tilt at least 30 to 40 degrees to move forward. As soon as the ship reached a nice spot for landing, it would go back to 90 degrees and slowly land on the surface. As you get closer, you can see the moon's surface just a few feet away. This is the tricky part, but it's a success. The team back on Earth couldn't be happier. The crew members are also thrilled about what you've achieved. You put on your spacesuit and gear and climb down the ladder. You leave your first footprint on the moon and look out at the distance ahead of you. The Earth is just a little blue dot far away. You're able to bounce around in the near-zero gravity. Now, that's what I call moonwalking. After spending much time on the moon, it's time to head back. Neil Armstrong, the first man to step on the moon, spent only about 2.5 hours on its surface before returning. But, oh no, you forgot the keys inside the ship and now you're stranded. Nah, just kidding. Although it would have made a good plot twist. You get back and launch the spacecraft back into orbit to reunite with the other ship above you. And once you've reattached, you exit the moon's orbit and head back to Earth. By sending humans to the moon consistently, the next big step can be achieved by landing on Mars. The famous exploration rover Curiosity traveled around the surface of Mars and gathered information needed for humans to land there. And NASA is aiming to have the first humans up there after 2030. The journey will be hundreds of times harder than the one towards the moon, but many scientific questions will be answered once it happens. Humans may be able to gather some of the natural resources there and even build outposts and colonies. There are endless possibilities as well as challenges. The journey from the Earth to the Moon is around 250,000 miles. Mars is around 35 million miles away. There could be a possibility of a new human outpost stationed on Mars, building a new society of scientists and engineers to make the most out of the conditions. It would be completely self-sufficient, providing proper ways for farming and agriculture. And by having humans on Mars for so long, scientists can properly understand the planet. But to understand how the human body responds to deep space environment, we'd have to have a lot of practice before getting that ticket to Mars. The closest experience of having a colony in the middle of nowhere is the Amundsen Scott Station on the South Pole. It's designed to withstand all the harsh conditions of the freezing dry cold. Being at the bottom of the world can be pretty stressful without proper practice. The journey may not be as far as Mars or the Moon, but being on the South Pole is like arriving on a whole new planet. The station itself is equipped to provide the proper conditions everyone needs to be comfortable. Besides the strong heating system, the station has a recreational room for sports and music, a library, a lounge, and even a greenhouse to grow all the right veggies and fruits. In fact, the greenhouse is the only way you'd get to feel like you're in a rainforest. And even before applying there, you'd have to get screened to see if you can handle the isolation for months. Not that you'd be completely alone, but still away from civilization. Antarctica's whole population consists of scientists and engineers, and you need to be examined by a doctor to determine if you're physically fit to stay there. The station is built there for scientists to study space and things related to geology. Being in the biggest desert in the world can take its toll on you. When leaving the station, you have to wear at least 3 layers of gloves and extremely thick sweaters and jackets to withstand the cold. They even compared stepping on the South Pole to walking on the Moon. Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the Moon. They named it Kamo'oliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. It repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long, long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet or had once broken off, There would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon, kind of like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system. And the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
Since 2007, astronomers have been receiving super-strong and ultra-bright radio signals that last just a few milliseconds. Such mysterious flashes are called fast radio bursts. They seem to be coming from billions of light-years away. Not so long ago, researchers were lucky enough to capture a repeating radio burst that flashed 6 times in a row. Who knows, it might help us crack the puzzle of these signals. But hold on, it's just the first mystery on our list. If nuclear pasta does exist, it's the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance is squeezed into spaghetti-like tangles of material. It can break, but only after you apply 10 billion times the pressure needed to shatter steel. That single, high-energy neutrino that hit Earth in 2017 wasn't extraordinary on its own. Scientists observe such neutrinos at least once a month. But it was the first one to arrive, carrying so much information about its origin that astronomers could actually point their telescopes in the direction it had come from. They found out that the neutrino had been flung at our planet around 4 billion years ago by a flaring blazar, a supermassive black hole at the center of a galaxy. Saturn's moon Hyperion is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity which is flowing out into space. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras illuminating the planet's atmosphere. When a team of astronomers at Louisiana State University first spotted this star, they were totally baffled. The object, nicknamed Tabby's star, dipped in brightness at irregular intervals and for odd periods of time. Sometimes the difference in brightness reached 22%. Could it be due to the activity of some alien megastructure? Unlikely. The main theory claims that the star is surrounded by an abnormal ring of dust, which causes the darkening. DJI-SAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters. It can mean that DJI-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Massive objects curve light so much that it can distort the images of objects behind them. When astronomers used the Hubble Space Telescope to detect a quasar from the early universe, they used their discovery to calculate the expansion rate of the universe. Strangely, they discovered that, currently, it was much faster than it used to be. That finding contradicted other measurements. We still don't know if our theories are wrong or if something bizarre is going on in our universe. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star. But this theory hasn't been proven yet. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most enigmatic thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Dark matter is believed to make up 85% of the universe, and researchers used to be sure it was everywhere. But in March 2018, a team of scientists discovered a peculiar galaxy that seemed to contain little to no dark matter. Later, though, it was proven that this space oddity did, in fact, contain dark matter. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this yet. Planets orbit stars, moons orbit planets, then why can't there be moons? Also known as submoons, moonets, and muons. Researchers claim that moons could exist. But the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Count how many times the word moon is said in this video. Enjoy! There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonetes, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile-wide submoon could only survive moving around a 600-mile-wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. and the rocks on the moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the sun and from space. But even though Saturn is protected by its magnetosphere, the sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese Lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon.